Professor, I feel like you said a number of things that you shouldn't have said about your.
All right, probably. That's why I have to go. No. What have I said that, what? I've really been good at cleaning up my act. There's a lot of things I don't say anymore. I've said worse. I'm tenured, so I'm a tenured full professor, so I have to say some pretty bad stuff to get in trouble.
What have you said before that you can't say now?
I don't know. So tenure. So I'll tell you what is tenure.
Professor, I thought you said.
I got rid of that.
And you'll stay here.
So here's what it means. Let me teach you some old school stuff so you can miss it longingly when it's gone. The reason why they tenured professors is because, look, this is a safe space for you to explore yourself. That's what we're supposed to do. But we also are supposed to be frank and tell you. I mean, when people ask me to keep a secret, I'm like, you know who you're talking to. You're talking to a freaking professor. We don't keep secrets. We share secrets. We are not the people you should involve in NASA or anything like that. And it's not because we have any ill intentions. We just want to share with you. We want you to be, you need to know what's going on. And if everyone's hiding the truth, like, okay, so let me just say something about mental illness that I shouldn't say. One of the nice things about me is people tell me stuff that they wouldn't normally tell their friends. There are a lot of people out there that are walking around looking perfectly happy that are not happy at all. And it's helpful to you to know this. So maybe you won't feel so bad. And that's sort of what education is. It's like, I'm telling you, you're not alone. But if you walk around looking at people, they all show their better side. They all pretend like everything is all happy, but they ain't happy. Okay. And what they're not happy about ranges from white collar, what is that? White collar. First world problems and third world problems. Some people have real problems. And I'm like, oh my, that's a reason to be sad. And then some people have like, oh, my fingernails chipped and my cat scratched me. I'm like, oh, boo-hoo. But it's not, you can't say boo-hoo. You have to say, everyone's problem is their problem. You have to respect their problems. But you have to know there's a lot of people with problems out there. Okay. And so I shouldn't waste class time telling you about this, but I'm just saying, just you look around the classroom, you look remotely, honestly, you don't see what's going on inside people's heads. But most people have insecurities, are depressed. A lot of people, I watched this video on money, not money, on happiness. And all these people said, we need for happiness. They all said money. Wrong answer. Money don't bring happiness to nobody, but everyone thinks it does. And that's why.
Are we sure that it doesn't bring happiness?
I watched a documentary on happiness and I learned something. And every time I repeat it, everyone I talk to agrees with me 100%. And that scares me because nobody should agree with me 100% on anything. I invite challenge. 3 things you need for happiness: family and friends. I don't like most of my family anymore, but I like some of my friends still. You choose your family and friends. So works for me. Keeping your mind active. So like learning, you're here learning. This can make you happy. It has an opportunity to make you happy. Solving problems, whatever. The third thing is charity. Helping other people. We are social creatures. We get, our brain gives us happiness when we do what we're biologically meant to do, and that is to help each other. We don't survive alone. So we have to help each other. But businesses have discovered, hey, if you help people, we can't charge for that service. If you help your neighbor, then that neighbor isn't going to call us to do it. So marketing has convinced us that we all have to have a lot of stuff, have to have money, buy a lot of stuff so that we can be happy. When all we have to do is be nice to our fellow man, and that would be so much better. And so you're nodding your head, but you see, those are the 3 things you need to be happy, other than money to survive. Like if you're starving to death, then yes, you need money. But most Americans are not starving to death. I have a friend who works at a soup kitchen. She sees all the saddest people in the world, and none of them are starving to death. So New Jersey is not a starving to death state. There's not a place in New Jersey that you're gonna find people like eating tree bark to survive. But maybe elsewhere, but not here. But anyway, there's my little lecture on happiness. So be happy by concentrating on those three things. And those are my three. I'm particularly aware of retirement, and those three things are things you need to do when you retire. Charity is, but my parents used to, my mom was part of the school board and she did all this stuff. She volunteered here and she went to the library and she did this and that and the other thing. And I don't see parents doing that. They're too busy doing other things, like taking their kids to soccer practice, which is not exactly charity. It's nice, but it's not charity. Doesn't set necessarily a great example to kids. Sorry. Did your mom take you to soccer practice?
Yeah.
Did she belong to the school? Did she do any volunteer work?
No.
Yeah, not a discredit your mom. I'm just saying that's our society's going. It's more of the we do stuff for us and less of we do stuff for other people. And that's why you're chasing happiness. You're not finding it because your happiness is. Well, I'm on top being recorded, so you can't tell me about your mom. But anyway, I forget what I'm doing. I'm recording and I'm not sharing, so let me share. All right, let's talk about what we have to talk about today. But happiness, we should always discuss happiness. And why is this course particularly good for happiness? Because it does help you keep your brain active. It is something new. Your brain loves to be exercised. When you exercise it, it releases happiness chemicals. Let's talk about that quiz then. That quiz was, we're on mod. Am I sharing? Can you people at home hear me?
Yep.
Kara, thank you.
Yep.
Sorry, I'm in a mood. All right, the quiz. So can I just, how do you want me to do this? Item analysis? Sure. Because if you missed it, it'll show up on the item analysis. Say the following. Can you say that? Okay. The sum from n equals 1 to 100 of n squared equals, okay, all that numbers must be 3030. It's that. I can't just put those in there or you'll know which one it is. So I put it in that way.
So would have the equal in there, but then it wouldn't have it in the same part, it's still kind of gray.
Oh, I don't know.
Some would be like,
This says is and equal to the same thing.
yeah, so like this one gives you the equal, but some of them.
Okay, well, let's see, maybe it'll come up. Okay, so this one doesn't have an equals. So this is just the sum from n equals 1 to 100 of f of the quantity 1 minus 2n. Okay. The sum from n equals 1 to 100 of the function of the quantity 1 minus 2n. Okay. That person got it right, though. Did we get to 100% already? Can't be. Well, they're not in order. Hold on. Worksheet. The small city of COVID. From weeks 20, so use the integral to find the total number of cases from weeks 20 to, okay. Copy, COVID cases. This is what I want. Oops, that's not what I want. Okay, use the integral. There's the integral. What between 0 and 22? Okay, that's how the game is played. And that's the answer, maybe. All right, so let me just let me explain this for a second. Here's the function. This is the number of, since it goes up and down, it must be the number of new cases. So each one of these weeks, they're counting the number of new cases. So a person isn't, if you get a case this week, it's not counted next week. Because if that were the case, the cases would just be going up, 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 up. If the number of cases were the number of, always cases, how many people have gotten it, then the function would just keep going up. But since it went down, it means the number of cases went down. So there must have been people that didn't, got it. So it should have been more clear in the instructions, but I'm covering this down because I want you to know that if a person's sick in multiple weeks, if it counts as a case this week and next week, then all bets are off. You're not going to get the total number of cases because a person is going to be counted more than once. But if a person is, so same thing, like if you count population, if you do this integral population, it's a problem because you're counting the same person year after year after year. But if you're counting the number of births, people only born once. In 1 year, they're born. People only die once. Okay. But if you count the number of people who have died, okay, that's going to be a person who died last, or people who are not alive. If you count the people who are not alive, then you're counting the same dead person year after year after year. And so the numbers you get are going to be way bigger. But you can find out the average number of dead people. You just can't find out the total number of dead people. As long as whatever the event is, it doesn't spread over into different X values. If it's in one X value, then that's it. In this case, we're talking cases one time. That's the answer right there, I believe. 85, 7, there it is. Which quiz?
I got them before.
Quiz 8? Sure, I will. I will in a little bit.
So I typed that same thing in.
8579,
Said a whole number, so I want me to.
and that's the answer that it's looking for.
Right.
This problem, you had 8579, and it was between 0 and 22, and it marked it wrong. I don't
And I
know.
like redid the quiz a few times.
Well, let's take a look at it. Let's take a look at your quiz. Do you mind if I pull up your quiz?
Definitely.
Hold on. Let me just see. This is the same one, but it's from weeks 2 and 28. So it's just a matter of changing this to 2 and 28.
To 28.
And the answer is 14,797.
98.
798. Yeah.
Right.
Okay. What else?
And that one I was thinking, I was like, in my head, that's.
Okay, how about this sum of values? The sum of values. So here we're adding up a bunch of values. Okay. Memorize that formula if you wanted to, but I think that would be wrong. Sum of values, that's f of x squared. Okay, so I create the function f of x. So an f of x, f of x equals x squared. I'm sorry, I'm going to do your quiz in a little bit. I just want to, when I do that, I have to close this, and I want to close this right. So let me finish this off. So there's the function, and I want to evaluate it at all these points, and I want to add them up. So let me just show you what that means. It means I'm going to create a table. You don't have to create a table. I'm just creating a table. Did I create a table? There it is. So for different x values, I want to know what the f of x is. And they're saying evaluate it at 0.125, 0.125. And then the next one is 0.25. Now with Desmos, I know if I just keep hitting that, it'll just automatically change the next one by exactly the same amount. Okay, so let's say we want to add it up to the number 1. I don't know what that's for. It changes for everybody. Let's say the number 1. Okay, so that means I'm adding up. How many of these am I adding up? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of them that I'm adding up. So I'll do summation. I'll start with, hold on, I'm going to add up the function. So hold on a second on f of, I'm going to put something in here, and it's going to be, well, I know it's going to start with 0.125. That's the first one. But then after that, it's increasing by how much? 0.125. And so I'll put a little n there. So that way it'll increase by 1 every time, and it'll add it up. Okay? Now I have to figure out, how do I get the first one, 0.125? To get the first one, that n has to be equal to what?
Here,
0. Now, how many do I want to add up?
8.
8. So what number goes there? If you're starting at 0 to get 8, 0, 1, 2, 3, 4, 5, 6, 7. 7 gets you to 8. So that number is a 7. Okay, and that would be the answer. It would add up to that.
And then if you did 1, it'd be 1.
If you do 1 to 8, that's fine, except if you do that,
You have to take away
you have to take take away the 0.125, which is really probably the way they wanted it done.
That's how I did it.
You did it this way and you get rid of the 0.125. So you have to subtract, you have to go back up by 0.125. And so that basically means this. Okay, same answer. I like starting at 0 because it makes more sense. Whatever number you think you have to go to, just stop there.
You know, multiply it by 2.
No, because this just says add them up. Don't confuse add them up with the area, approximate area. Those are two different things. They look exactly the same, but I can check this. If I want to do the area thing, I would multiply it by 0.125, right? Okay, and that gives me that number. But if I want to check it with an integral, I'm going from what? 0 to 1 of the function f of x dx. And the answer is about the same. Okay, so this, and that are area things. This is an exact, this one integral is exact area. This is an approximate area using 8 rectangles.
So you don't have to use that bottom one unless you're looking for the area.
Yeah, no, you can't. And they were just asking you for this. Add them up. If I ask you what summation does, what are you going to say? It adds things up. Look at all the different answers. I don't know which one you had, but that one was, oh, only one person got that question. They got a 0. Oh no, that's this one. 2 people got that question and they got a 0 on it. Hopefully it's not wrong. Here's, okay, so what happened here? This is lines 10 and 11. What's happening in lines 10 and 11? Okay, are we adding things up? I see summation, so it's only 2 possibilities. Am I adding things up? Or I'm finding, approximating an area? Just, you see there's no times 0.2. So yeah, this is just adding things up.
Over a few of those.
Sum the values of function evaluated at various points. Okay, use summation formulas to complete sum. There was no formula there. It was just there it is.
So what is the formula look like?
Those are formulas, or those ones with the parentheses, so the first term plus the last term. And so you have a summation and you're using a formula instead of just using Desmos. Desmos, you don't need the formula. Just use Desmos.
There's one where it's like all over 6.
Yes, that's one of the formulas. That's for n squared. I shouldn't say we don't need the formulas. We're not wasting the whole purpose of the formulas is going to become obvious to us later on in a very, we don't need this on the test sort of way. We have this problem that we have to deal with, and that is area under a curve. Just that integral means area under the curve. The fundamental theorem of calculus is the connection between the area under the curve and the antiderivative. But the only thing we understand at this point, when we're talking about area under the curve, you can understand a bunch of rectangles, can't you? If I asked you to count the tiles on the floor, each one of the tiles is square foot, you just add them up, right? That's area. That's simple and understand, but why is it equal to some antiderivative thing? That's where we have to get to. And that's why we're doing the summation so that we can get to where we need to go. But once we get there, we don't care. This is like finding the derivative of sine cosine. Once we're there, it's not something you're going to be like every day say. You're not going to tell your kids, I remember in calculus, when we were trying to do area, the fundamental theorem of calculus was proven by taking the limit as the number of rectangles goes to infinity and using these summation formulas. Because you can't do anything with summation Can't take a limit of the summation because we don't know how to do that. But you can take a limit of those formulas. That's why we do the formulas. So we switch from the summation to the formula so that we can take a limit and get a number just the way we always could do anyway. But anyway, that's where it's coming from. And I don't know how excited I am about this. It's not something you're going to see in your life. And it's not something your kids are going to say to you. Say the following: why are people not getting this? Is this the one that you got?
I mean, I got that one.
This one says that somebody got it right.
Yeah.
Why is it? Are we up to 100% already? Can't be up to 100%. Oh, we are. There aren't that many. There's only 8 questions on this. How can there only be 8?
There's 5.
I know, and everybody got different questions. So where are the other questions? Oh, see nothing. All right, we got to take a look at this. But this is not right. Where's the where's all the vocabulary questions? What the sigma notation, is that the only question there was? And only 2 people took the test? 2 completed? What? Okay, hold on. Now people are going to get in trouble because I'm looking. I have to look in the grade book. How do I look at the grade book without sharing? Stop sharing. So you guys at home are not going to see the grade book. No, that was not good. Sorry, I'm going to pause the share. You guys here have to look away. Look away. Look. Don't look here. Don't look. Okay, you can look now. 2 people took that test. I can resume sharing. 2 people. Devon, thank you. And Kara, thank you. You know that's due by the end of today, isn't it? Except it says it's due at 4 and you didn't even try it.
Please, I don't retake.
I can. Oh, look at Devon. He did so many.
Which
Which one do you want me to look at? I don't know which
Look
one.
at the 6th one, the 9.
The last 6 one or the first 6 one?
Either one.
All right, let's take a look at this one. What does sigma notation do? You got that? You didn't
This
say
one
any
wasn't
of
my fault because I couldn't see it, like blanked out, and all I could see was the bar.
it.
So I had to guess.
Okay, here you go. Number 8, you got it right. Use the summation formula. This is what question? What's
2.
22 and 23. So you got it right. 22 and 23.
I have no
Yeah,
idea.
you see that adding up, and that's the formula for adding up 67 ends. And this is the formula for adding up a number 67 times, just multiply it. So that's what that is.
So that's a
Formulas for finding summations.
okay.
Okay, so we got the summations right there in the first one. So the next line is using formulas to confirm it. Those are the formulas. Use summation first. Okay, that's sum. Okay, x squared. You go all the way to 2. So I just did that, didn't I? Except I only went to 1. Is this it? So we want to go to 2. So instead of doing 8, how many more do we have to do? 2. How many is that? 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. Good now. So I need to add up 16 things. So I'm going to go from 1 to, since I already set up this, I'll just go to 16. Come on, stop it. 16. 55.375. Wow, look at that. And then you multiply it by, yeah, so there goes that. Okay, on the test, if I knew that, I'd give you point.
I just have too many decimals.
That's not the same number. Look at the number. It's missing a comma, but you have 6 digits and that's only a 5-digit number. Look, you typed in 14,797 and maybe you wanted to do 0.8 to 1 decimal place, or it says whole numbers. So maybe you wanted to say, oh, you made it that 7 to be an 8, but you put both of them in there. Let me just humiliate you by doing this. Do you see it now? They're different numbers. It's not this is, if you, I'm just telling you this right now. I don't know on the test if I would give you points for this. Off the top of my head. I would definitely give you points. I'd have to watch the video, which I do when you miss a question on a test, like on the final.
Did it right.
I would watch the video, I would see you did it and say, oh, look at that, and I'd give you all your points. Okay, I don't give points for data, I don't take away points for data entry errors usually, especially this one. Okay,
No, they're getting mad because I keep getting one wrong, and I'm like.
This
it's not a
one-
good question.
this one you lose points for,
Gotcha. No retake it tonight.
okay? But let me just say this one you would lose points for on the test, but you wouldn't lose as many as the quiz takes away. Quiz doesn't give you anything.
Yeah.
I would definitely give
I
you
get
credit.
that partial.
You did great up until that last step. So I would look to see how many parts there was to this summation and getting that thing right. So I would say there's about 4 things you have to do. So you probably lose 1 out of 4 points. Okay, in this case, I would give you 2 out of 3 points because I'm not going to give you fractions. This one, I give you 2 points there too. So there. Good for you. Take it again, get better score.
Yeah.
Okay. I would have given you 3, but I can't look at your video. Okay, any other questions on that?
Can you go back to the one for like slides?
Oh, no.
It's it. Where it was like the number ones.
You're still looking, you're still just showing everybody's grades to everybody. All right, hold on. I gotta do this.
Yeah.
What about
There
this?
was one.
All right, hold on, I'm not sharing. Kara, I'm not sharing anywhere. I might stop sharing. Can you see it now? Naina, Mahir,
Yeah, we can see it.
who's here besides the 3 of you? Anybody else? Mahir, Naina, and Jacob. That makes 6, 7. Kara, Naina, Jacob, Mahir. That's 4 of them, 3 of you. That's 7. 2 people missing. All right, whatever. So what's your question?
I think it's 31 and 32.
Okay, is this
Yeah.
one an area or is it just add up a bunch of value?
That's the area.
That's an area 1.
I think
Hold on. It's this one.
Yeah.
What do you think? Is this an area 1 or add up a bunch of value?
It was a pie that was starting.
Now you're seeing it, aren't you? You see that
Yeah.
little thing, that incremental difference thing. If I do the integral of this, what's the integral going to be? An integral of what?
0,
From 0 to where?
10.
No. Anyway, let me put the function in. The function is f of 10, so we'll just put that in. Dx. We need to figure out what the upper limit is. You plug 0 into this thing right here, 0, you get 0 plus 0 is 0. So you're starting at 0. If you plug 43 in, what do you get? 43 over 44 pi over 2. So I think it's pi over 2. Okay, the reason why we don't count 44 over 44 is because we're doing one side. We always stop one before the last one because we're adding up a bunch of rectangles, rectangle. So we start on the leftmost side, start at 0. And then we get a little bump.
How
But then, how do I get it?
like, yeah, why is
It's
that?
right there.
Well, no, it's right there, but
Oh, how do I get it? I take this right here. Okay. And I say, okay, I'll do that. And then when I plug in for I is going all the way to 43. But it was 0 to 43. So really, if I'd done the right hand, it would have been to 44.
oh, okay.
And that's how I get 22. Okay, anyway, the answer is 10. And that's 10.177. So about the same. This is 43 rectangles. It's not bad. It's this function right here. There's this function, and it's pretty big. It's going up pretty high, 10 times whatever. And we're going from 0 to pi over 2. So you're really filling in that region right there. Oh, that one. That. Oh, only between That. This is the exact value. This line right here, 10, that's the exact value of this area. This right here is an approximation. Adding up rectangles. And because it's left-sided rectangles, remember I said there's left and there's right-hand side. Because it's left-sided, you'll see that the left side gives a bigger value than the actual value. Because the function's going down all the time. So if I do let me just draw a rectangle. If I do a rectangle, I fixed this by the way. If I do a rectangle like this, no, I didn't. That's a rectangle. You see it's a little bigger if I go from the right. If I do the exact same thing, but from the left, from here over, you see it's slightly less. It's going to be less than. So here, if I want the other side of this, I would start at 1. Start at 1 and go to 44.
Did that change your answer?
It did. My answer is less than 10. These are approximate answers. This is the exact answer here. Picture goes with this integral right here. That's the exact answer.
So which one would you accept on?
This is just on the homework or something. It depends what I ask for. Do I ask for a left side or a right side? By the way, you could do more rectangles.
Yeah, I saw that where it would be like from the left or the right.
Let's just make this a lot more rectangles.
So if it's from
You see what happens when I do more rectangles? I get much closer to 10. But I'm still, this right here is from, this is 45,000 rectangles starting from the right-hand side. And so it's a little less. If I start at 0 here, then I have to subtract 1 from here. Wait, do I have to subtract 1 or add 1? Subtract. Okay, and that means these are 8s also, and you see it's slightly bigger. Hold on. Yeah, it's slightly bigger than 10, but it's closer to 10. Starting at 0 gives you the first rectangle. Starting at 1 adds a little bit of the incremental difference. You're starting a little bit over and going backwards. Okay. All right. Ugh, no. No. Just no. A bad person. Can I not do any more of those?
Yeah. What's the area of the sum formula?
The area is a sum of a function with the incremental difference appearing twice. Once for the how to evaluate the function, and once because of the widths. So it's height and width, height and width, height and width. The ones you're just adding up stuff, those are just, there's no incremental difference there. Okay. Any questions on that? That quiz okay? That was quiz 8. Quiz 9 is due next time, but I have to go over the material today. Was there anything else from mod 8? Because we're technically, well, mod 9 was due on Tuesday, so I extended it. Questions in mod 9? Some questions on my mod 9. Okay, so we'll start with this first one here. What are the 2 types of integrals that we have?
Indefinite.
Definite and indefinite. Correct. Thank you, Devon. What do they tell you? I'm just going to do Kara, what does the definite and indefinite integral tell you?
Area and antiderivative.
Area and antiderivative, very good. Okay, the next question is, where can we have negative area? Jacob, where can we have negative area?
When the graph is below the x-axis.
That's correct. Okay, for our purposes, we can have negative area. We can have negative area in real life. So in other words, if I ask you the area of this table, it better be positive. But if you're talking about a function going below the x-axis, you're talking about, that could represent money that you've lost. If you add it all up, it's definitely lost money. Negative values still count as negative values in a lot of things. Okay, so, but it's negative whenever the graph goes below the x-axis. What does sigma notation do, Nana?
It adds terms.
All it does. Adds up. I always know when people cheat. Give me an AI answer for that. They give me way, way, way more than I want to know. I'm going to tell you something later, but I'll tell you about AI. How do we use sigma notation to approximate area? Have you been paying attention, Sarah? Add up heights multiplied by widths. Okay, save on, so now you understand that. How do we find the exact area?
Oh, sorry. Definite interval, or infinite.
Definite integral, infinite rectangles. Oh, you didn't say FTC. What is FTC? Do you know? Sounds like a curse word that's been abbreviated. For me, I don't know. Oh, why know I? Anyway, it's not. It's FTC means fundamental. Yeah. What's the question?
Oh, no, sorry.
There you go. You know, the thing is, this course is called calculus, and this is the only. If it's fundamental theorem, it's like the theorem of calculus. It's not a theorem, it's the theorem. Okay, we learned about a theorems. There were a bunch of theorems, squeeze theorem and whatever. All right, what does the fundamental theorem do, Anusha?
It sets the definite integral equal to the difference of the indefinite integrals.
Yeah, so take a look at it. So I'm not sure I'm gonna have time to cover it, but that's it right there. So if you have a definite integral like that, you want to see that? Let me blow it up. Oh, that's real good. That's the fundamental theorem right there. And it says, if you have a definite integral of some function, that's right, definite integrals area. Everyone with me? A is the lower limit, B is the upper limit. What you can do is, remember I emphasized the whole capital F thing? What's the capital F? Okay, no, capital F, what is it? The antiderivative. Remember I put it on the test. I was so insistent that you call it the antiderivative, and I took off points when people said capital F. It means something. It's the antiderivative of this little f. If you don't do that, you don't, this formula makes nothing. It's like my first month in chemistry class when I thought all little symbols were variables. I had no idea that carbon was a C. I thought it's just a variable. I was like, what the hell are you talking about? This capital F means nothing if you don't know that it's the antiderivative of this little function in here. And what you're doing is you're taking that antiderivative and you're evaluating it at the upper limit, and you're subtracting the antiderivative evaluated at the lower limit. That's how that's what the fundamental theorem does. It relates the definite integral, boom, right there, to the difference of indefinite integrals. Those are indefinite integrals. Okay, those are antiderivatives. Got it? Mahir, you get the last question. How do we find the average value? Mahir. Yeah, I'll turn it on for you so you can say it. If you don't say it though, I'm not gonna be happy.
Yeah, 1 second. Divide the area under the curve by the length.
Very good. That's the average value. Okay, so the area is just so back to this thing right here. Where was it? I just had it. This one. Remember this one right here? See that area in green? If I take that area Copy. Paste it, and I divide, that's the area, and divide it by the length. What's the length here? In other words, what's the length, the limits that go from where to where? Where is the length on this? Where's it going from? 0 to where? Pi over 2. So pi over 2. When I do that, oops, what happened to my dx? When I do that, I get this number. So the area under this curve is 10, but 6.366 is what? It's the what? When I took the area and divided it by the length, I got that. I got this. Let me just graph it for you. See that line? That's the average value. In other words, if I took, let me see if I can fix this. I don't know why it's not nice to me. If I take this piece right here, see this piece? And I try to fill it with this right there. If I pour that in there, all of this would fill in that space right there. Okay? And then you have a rectangle whose average value is this 6.36, whatever it is. That's the average value of this function. That means if you added up every value that there was and divided it by how many times you added it up, you would end up getting 6.3. It's like if you added up all your test grades and you got 6, it's the same as if you had gotten 6.3 on everything. Okay? I want you also to notice something else about average value. Up to this thing. What does this look like to you? Does that look like another formula that we've seen?
Average rate of change.
Yes, it looks like average rate of change, doesn't it? I asked you this question a lot. Showed up on tests, quizzes. If you don't know this, you're in. It's also just the slope of the line or whatever, but that right there is the average rate of change. Or the slope of the secant line. This right here, when you do the antiderivative, you get the average value. So if you're asked something average, it's going to look like that. People make sometimes taking the derivative. These are antiderivatives. So you undo the function. Okay. All right. Anything else about that? Those are our questions. Everybody who's here should get points. Okay. Did you guys post in average value yet? Because I think we spent some time on it. Maybe not.
I think we were last discussing what our personal projects were.
There's no posts here. But there is a post, there is a space for it, so we can put stuff there later. And let's go back to mod 9. Okay, so let's take a look at the home now for mod 9 and see if we can do this. So first question says round your answer to 1 decimal. Compute the area of the integral. So this right here looks pretty simple, right? It's just the integral from 0 to 6 of some function. But then it tells you there's this function in this crazy way. What are they saying about the function when they say it that crazy way? They're saying, okay, I'm saying graph the line y equals 3x. That's the graph of the line x, but it says if x is less than 1. So we say x less than 1. Okay, that's a piece of a function, right? Do you see it? Okay. The other one says y equals 8, but only if x is greater than 1. Okay, that's what this crazy function looks like. And then they say find the area but they want you to do it this way. They say, okay. They say, I'm editing this. So by doing that, you see, I got them to fill it in like so. That's the area they want. And this other one, they want this area. They want that. Are y'all good with that? They want the area of the blue thing and the area of the red thing. Oh, except they say only integrated between 0 and 6. Well, I got from 0 to 1. How do I get it to stop at 6? I just say, I just say 6. There we go. That's what they want. Now, you do not need no calculus to do this. Can you tell me the area of that red box? What's the area of that red box? It's 5 along the bottom. 1, 2, 3, 4, 5. And how high up is it? 8. So that's 40. Okay. And what about this triangle? What's the area of that? It's 1 along the bottom and 3 up. So what's that? 1/2 base times height is half of that. 3/2. So this is 40 and 3/2 or 41.5. Okay. But you can do this. You can break it apart into, look, you can do it this way. First, I did the fancy thing. I broke it apart from 0 to 1 and 1 to 6. And then I put in for the function between 0 and 1, the function is just 3x. And for 1 to 6, the function is 8. Okay. And honestly, if I just put it into Desmos, it tells me the answers. I just copy this. Paste it, the answer is 41.5. But I can use geometry and I can see, well, this one is 1.5 and this one is 40, just like we just did. Total is 41.5. Okay, anyway. This is just showing what I just did. Anyway, any questions on that? Question number 1. So for this type of question, the hard thing is realizing that this is a piecewise function, but it's meant to be done geographically. But you can do it any way you want. Now this one says use the fundamental theorem to compute the integral exactly. Okay, so here's the problem. I see the answer right there. And the exact answer is minus 80 over 3. But we have to use the fundamental theorem. If it says use the fundamental theorem, we have to use the fundamental theorem. Okay, now I can't do the antiderivative of this, but what can I do first so I can take the antiderivative of it? It's all messed up. There's like bits and pieces of stuff, but could I just distribute that x and make it x squared and 6x? Could you give me the antiderivative of that, maybe? What's the antiderivative of x squared? You're the one who's complaining I didn't ask enough on the test. Okay, but the antiderivative of x squared. The derivative would knock the power down. So start with the derivative. Derivative knocks the power down. It would be like 2x to the first. It's not that. Antiderivative is the opposite of that. So it's going to raise it by power. So I have x squared, so it's going to become x cubed. And then it's got to have that over 3 thing. Yeah. They all have the same number in the numerators they have in the denominator. Okay. So, and then what's this? Minus 6 x. You're going to raise it by power, and you're going to get what? X.
To the third.
It's already to the first.
Oh, squared over 2.
Okay, so that's the antiderivative. So I don't know if I can do this. F of x, capital F of x equals this. Okay. And then to use the fundamental theorem, I have to say, okay, this right here is equal to the antiderivative evaluated at what? Top value. What's the top value here? It's the upper limit. Or minus antiderivative evaluated at the bottom, which is what? 0. So all I have to do is evaluate this thing at 4. So all I need is capital F of 4. So what is capital F of 4? So same answer. Okay. But I used the fundamental theorem of calculus because I found the antiderivative. That's all I did, is find the antiderivative. That's what you need to do to get credit for this problem, is find the antiderivative. You can even do it this way, you can let Desmos evaluate it, I don't care. Okay, once you've written down that that's what you want to do,
So if it was two, you would, so if it was 2 and 4, you would evaluate it at 2 as well.
so that's a very good question. If there was a two here, okay, that's that number. And so then you'd have to subtract f of 2. So you can minus f of 2, going to be a smaller number. That. You plug 2 in and figure out what it is. You know, you can plug it in and figure out what it is if you want to do it by hand or just let Desmos do it. Okay. All right. This is an integral that you have to do this integral because it's got variables. You have to use the fundamental theorem. So with the fundamental theorem, what's the antiderivative of 20? What's the antiderivative of 20t cubed? 20t to the what? T to the 4th and that's the antiderivative. Now I have to evaluate it at the top limit. So I'll just say this t equals what? What's the top value here? Okay. Equals x. So I'm just going to plug x into that. And then I'm going to subtract the exact same thing, except t is going to be equal to what?
2.
2. I don't have a good notation on Desmos for this, so that's what I'm doing. So when I take this and I plug in x, what do I get? I just get the exact same thing, only I put in x instead of a t. Like that. We're good? Minus. This one, we have to plug a 2 in. So what's that? 2 to the 4th power is, so we'll take this right here. And we'll put 2 to the 4th power is what? Okay, you don't know what that is? I'm just going to take the whole thing of Desmos to. Can't do it, Desmos can do 80. Okay, so the answer is going to be equals 20 over 4. So it's 5x to the 4th minus 80. And that's what this is. That's the answer to the middle. So this answer is a function. It's not a. I wonder if did it. Just out of curiosity, sometimes Desmos is kind of awesome. If I do y equals this, it graphed something. Totally, just crap, too much crap there. Hold on, let me just get rid of this. Go. Out. What?
How do you get 5?
I don't get 5?
Yeah.
20 over 4.
Oh,
And is anything else on? No, I think that's it. So Desmos actually did the antiderivative parts. Who knew? All that stuff I did to get 20x to the 4th, Desmos did it. It gave me this graph here. Let me just change the window a little bit so we can see it. Maybe a little more wide. Well, that's what it looks like. It looks like x to the 4th. It does. It totally looks like x to the 4th minus some number. Can you see it now? That's what x to the 4th looks like. It's actually 5x to the 4th minus 8. Okay. But I just asked it to graph it and it did. So clearly it can do what I just did. It just isn't going to tell you that's 5x to the 4th minus 8. There may be ways of coaxing it out of Desmos, but that's not really what we're trying to do. So here's another one. You have to do the antiderivative and plug the x in. So what's the antiderivative of this function right here? So let's copy this down. What's the antiderivative of x squared? X to the cubed over 3. What's the anti? Oh, come on. What's the antiderivative of 3t? 3t to the squared over two. Well, Dave Vaughn's gonna do well in this test. It's the antiderivative of just the number 4. No. Antiderivative.
Oh,
What's the antiderivative gonna be? Not x. Plus what? Plus a constant, I don't care. For this, I don't care. That's the antiderivative. That's capital F4 of x equals this. That's the antiderivative. Now, how do I use the fundamental theorem of calculus? What does it become? I take this function and I plug in the top value. It's the top value. Top value there that I'm plugging in. Just x's. Fine. So these are x's instead of t's. Got it. And then minus, I do the same thing, but instead of those, I plug in what value? 0. So this is going to be 0 cubed, 0, 3 times 0 squared, 0, 4 times 0 is 0. So there's a lot of zeros and nothing. It's just going to be that right there. Okay, if I ask it to graph this function, oh look, it already did it. So if I ask it to graph that function f, it'll do it. It totally did it. That's that red line. But if I say, oh, this one has a problem because it's, let me change these. This is f of t, antiderivative of t. But if I wanted to graph the antiderivative with x's, let me just see if the x's will do it. Did it graph it? It's the same graph. Everyone go with that? So it doesn't almost totally checks your antiderivative. It can do it. It can do the fundamental theorem, which is I'm going to tell you what it is. The answer is that. It's just that. Which is the same as this. Which is the same as that. Okay? Just when it says evaluate the limit, in this case, it's going to have an x in it. Because this is the area under the curve between 0 and some x. We'll tell you what that x is later on, but for now, it's just some x, it's some variable. So you can't graph it without saying what that x is. So, I mean, you can't get a number unless it's a number like 2. But if you say x, that's just saying this is a function. This is not an antiderivative. It's not an area under the curve. It's an area of the curve that depends on what the x is. So you tell me the x is here, I'll tell you what the area is. You says x is there, I'll tell you what the area is. That means it's a function. Okay. All right. So number 4. Number 5. I'm not going to do number 5 because that's the time this week. Okay, so number 6. Find the area bound by these things. Y equals 3x squared. That's this one. Oh. There's y equals 3x squared. Something's graphing. There's y equals 3x squared. This is x equals 1. And this is y equals 0. So they want that right there. They want that area. Now, how can I get that area? Anyone? Exactly. Sarah, you can tell me this exactly. How do I get the area? Oh. How do I find the area of that right there? No, it's Pythagorean. It's not a triangle, it's a curve up here. We've set up an integral of 3x squared between 0 and 1. So it looks like that. So what is the area in that orange space? Which if I click on the circle, it's that area right there. What is the area of that? 1. Thank you. Now, what's the average value? What's the average value of this function?
You divide it by 0 minus 1.
The other way around, 1 minus 0, and you get what?
You have 1.
And so 1 over 1 is If you were to graph y equals 1, just so you know. Y equals 1. You see that? That's the line right there. So that's area right there must equal that area. It's like there.
So you take the bottom minus the top, not the top minus one.
No, it's the top minus the bottom.
Just like
1 minus 0. I used 0 minus 5. Or I thought I heard 0 minus 1 minus 1 minus. Whatever. I am meeting live stream, so we can we can at least check the. How's that live stream shuts people up? It does. Okay, so here's a question. Find the shaded region. Look, I got to talk to you about this. It's important that you know. What did I say about the area of this table? Okay, who was the one? Oh, it's I think it was Moment. Hey, Moment. Are you there? It's not Moment. It was Mahir. Mahir, are you here?
Yes,
Mahir, how do you get negative area?
I don't know.
Really? You don't know? Anyone want to tell me how we get a negative area?
It's under the x-axis.
It's when the graph is under the x-axis. Look at this graph. Do you see how this blue thing is under the x-axis? That would be negative area, right? And this one up here would be positive area, even though they're both blue. The difference between this question and the question of life is, this says find the area of the shaded region. A region can only have positive area. In calculus, we have negative area whenever the graph goes below the x-axis. So that makes negative numbers so that our business people can be happy. They can have negative numbers or even temperature. You can have negative temperatures. When you add them all up, you don't want it positive. But this is saying, what's the area of these two blue regions? As if they're both positive. We use integration. The first region up in the upper left corner, that would be positive, but the one over here is below the x-axis, will come out negative. So what you have to do in order to find the integral, there's a few ways you can do it. You can take the function, you can find the antiderivative, but you can break it up into parts. You can go from -1 to 0, that'll give you a positive value. And then you could subtract the negative value from 0 to 2, and the answer is 3.08. Or you can use fundamental theorem of calculus to get 3.08. Or the easiest way is to just put the absolute value in. Let me just show you what the absolute value of this function looks like so you can see it. Look at the difference between this function and the same function without the absolute values. So the purple one is with the, do you see how the red one has positive area here and negative area, but you see the absolute value, what it did was it flipped the function up so it's positive area only. So that's the easiest way to do it, honestly. If you're asked the area of some regions and they're both regions and you want them both to be positive, just put the absolute value in and you don't have to do any other work.
You get your variables for -1 and 2.
Because in this graph here, because you see the graph goes from -1 to 2.
Oh,
the whole thing goes from -1 to 2. And if you get the absolute value, you can just do the whole thing. But if you're doing a positive part and a negative part, you have to go -1 to 0. That'll be a positive part. So let me just show you.
I see that.
Oh, okay. Right. Any other questions on this? Can turn it off. Turn it off. Why is it still there? Here. Okay, moving on to number 8. Find the area of the shaded region. Okay, so there's a new shaded region. So what can we do? They tell us the function is the absolute value of x. So what's the area? What's the area going to be? Integral of the absolute value of x from where to where? -1 to 1. Come on. Good done with geometry too. It looks like a half and a half. Nothing else to do there. Super easy. None of it was negative anyway. Find the area of region. Here's another area region. Okay, where's that picture? See it. There it is. Okay. So you want to go, this is find the area of the region. So if we're going to do this, how do you want to do this? Do you want to do it with geometry? Do you want to do it with, what do you want to use? I would do it the easiest way for me. It's just to type in the integral. The first triangle is going from where, the first region is going from where to where? -1 to 0. What's the function there? It says it in the right corner. 1. That's one of them. So that's there. If you did a geometry, you would see, well, that's one box and that's a half. So 1.5. Okay, fine. How about the second region? That's going from where to where? That's the integral from 0 to what? 1. Oh, what's the function? It says it right there. 2 minus 1. Say it. Sarah, are you saying it? Sarah, what you doing? She's not even listening to me. Sarah! Was talking to you and you weren't even listening. That. dx. Okay, so what is that? It's 1.5. Also, do they look like they're about the same?
So it's not x squared.
No, they're wrong. That's because I was asking Sarah what it was and she wasn't paying attention. Now it's 1.6 bigger. It does look bigger, doesn't it? Now it's a little bigger. What's the last one? I could just add that. That's 1 times a half. That's a half. So if I add these up, if I add this one plus this one. Plus, if I want to, I can do the integral from 1 to 2, integral from 1 to 2 of 0.5 dx. And get the answer 3.66666.
So you couldn't just add it to 0.5.
What? I could just add it a half if I want to. Whatever you want to do. Okay. Sarah, you listening to good music? Is that why you're ignoring me? I know good music when I see it. Okay, so 9 and 10 are special. Let me get to number 11. Let's do 12 first. Find the average value of this function. What's the average value function? What do? There's a function h of x. How do I find the average value of it? Remember that formula? It looks just like the average what? Rate of change. So I did, except I don't do little h. I do what? Capital H. So I do capital H of 6 minus capital H of 2 all over 6 minus 2. I need capital. Oh, where is capital H? Oh, because I already have it in the answer. Decimals. So what is capital H of x? What's capital H of x? What's the antiderivative?
Oh,
X raised to the
third.
root over 3 minus 2x. That's the antiderivative, and you can just do that formula if you want. Okay, you do that formula, that's what you get, 15.333. Okay, or you could do it this way. You'd say the integral from 2 to 6 of h of x dx. That's 61, and you have to divide it by what?
6 minus 2.
6 minus 2 minus 15. Did I do that one? Okay, now I have to do the last two. These are hard. 10 and 11 are hard. So why are they hard? find the position function. I did not ask this question, so let's see if anybody showed up that I can answer the question to. Anusha,
Yeah.
wait, what's the relationship between position, velocity, and acceleration?
Velocity is the first derivative of position, and then acceleration is the second derivative of position.
Okay, so let's just start with this one. Okay, so I have the derivative here. I will need to find S, and I have V, right? So I have V of t is equal to this. What is it? I have V of t. It's this. And that equals S prime. I need to undo this derivative to get rid of it, right? How do I undo a derivative? Is a derivative undone?
An integral?
An integral. So we have to put in integral here. We have to put in integral here. Okay. And so what's the antiderivative? Oh, which means we have to put the dt in here. What's the antiderivative of 20? 20 what? T. Let's see. Plus, what's the antiderivative of cosine? Thank you. Of what? T.
That's that cost.
The cost. And so then that's S of T. What am I forgetting here? What am I forgetting? When you do an antiderivative, there's a plus what? C constant, right? Now we go back to this thing. It says S of 0 equals 4. So let's take that information, write it right here. Okay. So I have S of t right here. In fact, let me write it this way. If you don't mind. I'm going to put the S of t in front. That did not work out, but it's okay. S of t equals that. And S of 0 equals 4. S of t equals this. And C is some unknown. And S of 0 equals 4. What can I do to figure out what that C is? Okay. Not 4. Write this right here. Okay. And plug in zeros. Isn't that what S of 0 is? Isn't that what S of 0 is? I just plugged in zeros. And what if I plug, what's 20 times 0? The sign of 0. So 0 plus C is just C. So S of 0 is equal to C, but S of 0 is also equal to what? Okay. My age is equal to some unknown, C. My age is equal to 4. What is my age equal to? What is C equal to? My age is C, and my age is also 4, then C must be equal to 4. So you have the function. So answer this question is, it's S of t. You don't give the answer with the plus C in it. You say specifically that S of 0 equals 4. And then it can graph it. Couldn't graph it before, but it can graph it now. This is called an initial value problem because they plug in 0 is usually an initial value. If position is S and S of t and plug a 0, that's your initial time. Okay, so it's an initial value problem. And they did the initial, they got the initial value and blah, blah.
That's your answer.
And that's my answer, just there. So I did it once. For the next problem, I'm doing it twice. Who's going to help me do this one? I need, Anusha, what's the relationship between acceleration and let's start with velocity. What's the relationship between acceleration and velocity?
Acceleration is the first derivative of velocity.
Very good. So now if I want just velocity, what can I do? It's this. If I want to undo this derivative, what do I do?
Take the integral.
Thank you. So take the integral both sides. Integral this. Dt. Equals the integral of this. Dt. So that equals velocity. Okay. Now, what is the velocity then? So let me write the velocity here. V of t equals this. I'm just copying this, paste it down there. Okay, so now it's copied and pasted. So what's a of t equal to? They give it to you. It's 8 minus t. 8 minus t. So I'm going to replace this with 8 minus t. Gotta get rid of the a. Okay. Can anyone tell me the antiderivative of 8? Eight t. What's the antiderivative of t?
B squared over 2.
Plus what?
C.
So there we go. Now we have velocity. Now we're going to use the initial value. They gave us an initial value for v. They said v of 0 equals 4. Okay. So what does that mean? 0 equals 4. We copy this whole thing down. So that's what v of t is. Uh-oh. So let me get rid of this thing here. So they say v of t equals that, and v of 0 equals 4. So what happens if I take this whole thing right here and I plug in 0? What do I get? 8 times 0, that's 0. That's 0 squared over 2, that's 0. Plus c. So this whole thing, when I plug in a 0, I end up just getting c. So v of 0 equals 4, v of 0 equals c. So what does that tell you? C equals. So if I want the answer, I just have to type this whole thing in. And that saves us 4. That's velocity. But I'm not done because there's another initial value. We want position, we don't want velocity. So what can we do? We can say S of t equals the antiderivative of this thing right here. I'm kind of getting lazy and skipping it, but okay. So I just have to do the antiderivative here. And what do I get? 8 position equals 8t what? Square root of 2. What's the antiderivative of t squared? T what? Cubed over 3. Uh-oh, there's a 2 already there. So what can I do? The 1/2 would just be times 2, so it would just be 6. Plus what's the antiderivative of 4? 4 t plus c. Okay, when you go to s of 0, it says s of 0 equals 0. So when I plug 0 in here, oh, what's my problem? Here it is. When I plug 0 in, that's going to be 0 minus 0 plus 0 equals c. Okay, so all of that is just going to be equal to c. And it's supposed to be equal to 0. So c equals 0. So I'm just going to do this. I'm just going to make it go away. There it is. It's gone. And that's the answer. That's the position. I had to do the antiderivative twice. It did an initial value problem twice.
So it's not 0, it's about.
No, it's not. They ask you for the position.
Oh.
For the question is find the position function given those initial values. Okay. And that's that. All right. Anything else? Did I cover everything I wanted to cover? Let's break up into our groups. And do the average value. No, we gotta get this done because it's due today. Is it due today? I'll extend the quiz. You guys work on 8. On postings. Did you do your, what was 8? 8 was
Coming up with. What you want
Proposal?
you know. About us.
Oh. Oh, so 9 is the area average, so this is the one that's due next time, so we gotta work on that. But again, you should, there's not much to do with that, it's already in the sheet pretty much. You just have to get the information down, remember? Again, you just go down here and do the area average value, turn it on. Want the area that's the area, that's the average value. The area is in this case, it's just, make sure you do the units. Equals 10,800. Yeah, stuff is due tonight. Supposed to be due on Tuesday. 10,800 mile times hours. And this one right here is 540. Just miles. Make sure you put your units in if you're the writer. And make sure you don't have, make sure you put actual numbers in instead of like A1, B1. So the writer should do this and have the numbers and the units in, and the speaker just has to say, according to the Gordic regression, between 0 and 20 hours of travel, there was 10,800 mile hours. Okay, mile hours doesn't make any sense. So you have to say, and that represented an average distance of 540 miles away from home. Okay,
Is that average value or approximate area?
is it what? Oh. All right, let's break up into our group. Was due last time. Here's the proposal slightly different. Do it so I can approve it. Because if I don't like it, I'm going to say no. I'm going to pick another topic. If you can write it in a way that I think it's understandable, I'll say get data. And then you'll get the data. But for the proposal, it's a little different than the other ones because you might change you might change it. All I need to do is approve it to make sure that, oh, I'm not approving. This is not a judgy thing. This is a, oh my God, you're never going to be able to do that thing. If you think you're going to be able to do something, like there's certain things that don't work. Feelings, attitudes, those things don't translate well into math. Maybe if you're a psychology person, you can convince me that you know what you're talking about, but mostly people don't. The other thing that doesn't translate well is linear stuff, things that are in a line. Like if I eat 1 apple, I got 100 calories. If I eat 2 apples, that's 200 calories. So I ate 3 apples, that's 300. If it turns out to be a straight line, it's going to be horrible. Everything is going to be bad. Hard. You won't be able to find any inflection points. You won't be able to find any max mins. You won't be able to find. It's all going to fall apart. What?
Like birth rate linear? Like how babies are.
Do you think birth rate's linear? I don't think so. Why are you interested in birth rate? Having a baby. That's the other thing. I need to know it. You're going to bring a baby into this world.
Yeah, like it's a bad thing.
No. I'm not going to say anything. Maybe they'll fire me before I could leave. Birth rate in US over the years between 1920 and 2022. Here you go. Here's birth rates. Look at that. You can get these birth rates. Does it look linear to you? Does that look linear? That means every year it goes up by the exact same amount.
Oh,
Does this look like it's going up by the same amount each time? Oh, you're going down here. This will be fine. I approve. I'm not saving this website for you though, so you have to find it. With all the fancy Googling I used, you probably never find it.
I just watched the recording.
This is with the. All right, let's break up into our groups. Do you know what room you're in?
So we're just posting that, right?
How many breakout rooms do we have in this class? Just two?
Two.
Okay, so who's in what room? You just have to post. It'd be nice if you posted a picture. If you're the producer, a picture would be nice. But it's right there. It just says turn it on. Literally, I just clicked on these things. You can just click on the whole thing and it'll come out. Okay? If you literally just click on the circle, it pops up. And if you open up the circle, you can go down and see what it's doing and get those numbers. So I need these numbers and that picture, and you're good. Who's in group one? Who's group one? Is that the business group? Or is that your group? Giovanna, you're not you and Sarah are both not group one. You're group two, right?
Yeah.
And who is in your group with you? Jacob, Mahir, Anusha. Are they in your group? Anusha and Mahir?
She's an artist.
She's in your-
I'm in the group with like Mahir, Kara, Suhavi, and yeah.
Oh, okay. So who?
Jacob and Nate.
Jacob and Nana and yours. So one of you has to log on the computer and talk to her. I see someone with a computer. Sarah,
That is.
go to Zoom and join the group. I don't see anybody in the room. Why ain't nobody in the rooms? Oh, they're not open. Sorry. Go ahead. It's my fault. Sala is in the online class. Jacob. You good?
Professor, is it student Wi-Fi?
What?
You know, student Wi-Fi.
No, I think it's your password, like your own stuff. Devon was here today. Cameron was here today. Here was here today. Nana was here today. Alicia was here today. Melanie was not here today. Suhabe. Where was Suhabe? She didn't come in today? Nyla wasn't in today either. No, I don't think so. I'm liking her absent now. Great. Suhabe. What does she look like?
You know, it's a kid's long term. So you know,
Where does she sit? That means a lot.
Yeah, they can live right.
You all sit over there. That's, oh, I don't remember right now. All right. Mahir, what group are you in? Why is somebody with you? The new shot
I'm
is.
with Suhavi and what's it called? Kara.
Are you in with a new show?
Yeah.
All right, well, so you're in room one, so she's waiting for you.
Yeah, it's not letting me join. Oh, okay, now it is.
Are we good? Sure, get in there and join the room. So all three of you are in the same group. So I have to do a demonstration next week.
What's this week?
What?
I thought it was this week.
It's next Friday, the 15th or whatever.
You're at the beach?
My speech is how to do this high flex. That's basically what we do. And I just was running it over with somebody and they were more interested in your tests, the interview tests, than they are in the fact that we can work in groups here. Like I like that you guys could be here or at home or both. And I thought that would be a good demonstration. But they were more interested in those interview tests. Are they more interesting to you or not?
Well, I mean, it's definitely a newer concept, like that's very different than any text that. Especially when it comes to.
And do you think, this is what's important to me, when I do a demonstration or somebody demonstrates to me or talks about anything, I want to know, how do you prepare somebody for an interview style test? Do you think that the way I have this course set up, where I have this, where we do the questions, this way, is that preparing you for this interview style test? Do you think the test is not too crazy?
I know definitely pretty good because it's like kind of recall when it comes to actual tests, like I'll see a question did. And because I heard it, you say it, and my classmates say it, something like that, so I just like. I recall it in the middle of the test, so those are like the easiest questions on the test, so those are. Like funny enough to say it out loud, the ones where we actually have to speak to the camera are the most beneficial, I think, because it gives us a chance, like that's how we remember stuff, that's how when we interact with like the test that we take, that's how we are able to.
That's why I'm
gain that information. So I think those are the easiest questions on there, and then the more quote unquote difficult ones will be the ones where you have to, actually then.
Oh, the problem.
Yeah.
So one of the things I've always talked about in education is what I call the buffet. The buffet is when you have lots of different ways of learning things, lots of different types. So I think that my 5 different categories are like 5 different things. You may or may not be good at one or all of them. Do you see that here? Do you think this gives you an opportunity to accept? I mean, you're not just doing problems. That's what you're used to in a math course, right? Just those ones you said were hard, just like. But the other ones, are they interesting? Do they add to your buffet of learning? And maybe sometimes you do.
Because they're different, so it's like it gives you ample opportunity. So like if I'm not good in one area, I'm like it like learn more about another area. And it like basically like picks up where you're lacking. Because it's different. It's not just one string thing, they're all the problems. You give me the answer, like you do the work, you give me the answer like that. And then if you don't, or if you aren't good, you're not sufficient, because sometimes people know that they're, when it comes to computing, they're just not sufficient. You're not sufficient, you fail automatically. It's different with this test.
But you have different ways of catching your intelligences. That's what I feel. Some things you're good at, some things you're not good at. But just giving them a bunch of problems, solve would make it.
There's no negative.
No. Oh, good. That was great feedback. That's what I like to tell people is if when it comes to these tests, it's not enough to have an interview style test. You have to prepare the students for the test. I mean, I could just have an interview, but you'd hate it. You wouldn't know what the hell am I going to do in an interview style test, but you've taken 2 of them so far in the first one. Then the quizzes sort of help you. They give you some guide, they ease you into what's actually happening. That's sort of what I'm trying to say. And you're confirming that, but Dave, you have something to say.
I don't like the speaking portions, but that's because
You like that solve the problem.
yeah, but I don't mind doing it. So it's not hard
They're not
to
hard.
adjust, yeah. Like,
Probably.
but no, but when I took the quiz when it was first like the test, I hated it.
The first test.
Yeah, the first test, I hated it. But for the midterm, it was alright. Wasn't too bad.
And it's gonna get, you think the final will be, you're not,
I hope the final's better.
well, it's gonna be the same. It's not gonna be better. It's not, I don't think it's gonna be better.
Yeah.
It's just if I feel like I'm giving you. I feel like the minus of all of these different intelligences is that if you're just a solve and chug sort of person, like you might be Davon, and you succeed at that, there's just not another opportunity to make a mistake somewhere. So it isn't necessarily for everyone, but it's not bad. I mean, if you're smart student, you can do it. And I kind of like those questions. When I ask you what is calculus, and
See, and that's what messing me up.
no, but see, you answer
Something
it
simple like.
I never, but you know what I say that when I give you a test and you answer it quickly and then you quickly say, oh, nope, it's not, it's a language, and you correct yourself. I take any point, you know, I didn't even notice that. I don't take off any points for that.
Study of functions is.
Are you guys hooked up yet with your group?
Every-
Jacob O'Dine is in there. Yeah, I don't take off points for that. Yeah, but I don't take points off for that until you get, I mean,
Study change.
yeah, that's an opportunity to make a mistake. But honestly, you know what's gonna happen? Those questions, I just think are so important. They're so easy.
There's like 30 vocab words or vocab terms in there. And like, you're only gonna get two of them, so you gotta know.
You're gonna get five on one.
Oh, fine, okay,
And by the way, come to my reviews because I weed out a lot of them.
okay, okay.
You see, I take out all that stuff that's like, what does the chain rule say or something? If it's really complicated, I might ask.
That one.
Well, I might only ask one of those complicated ones. You'll notice I would start off with an easy one, like what is calculus or what is math? The first ones are always really easy. And then they get harder.
In the area of change. Instead of rate of change.
I have a question.
Yeah.
about,
Go ahead, ask.
For the area and average value, what is the, like, as the. Yeah.
It's just the last one. Did you turn it on? Did you click on the circle to turn it on? Did your little folder turn up like that? When you open it up, it looks like this. First, turn it on. And what will happen is it will pop up automatically like that. Did it do that?
Yeah.
And all you have to do is open it up. And you don't have to change everything, and then scroll down to here. And now you shouldn't have these things because I added them. Just should have a number there. And a number there. Okay, so this one right here is the area, but that's the area, and this one here is the average value. Area, average value. But if you're the writer has to include the units. So the writer is going to write this equals 10,800 mile hours. Put a little times in there. So that's what the writer will write. Okay, and then this one will be 540 miles, like that.
We're technically like 3 other people in our group as well.
Yeah, but are you talking to them? It's online, right?
There's only like, what, 3 things to do on this assignment?
Well, you can pick different, you can do it this way. You have a writer and a speaker that gives this, or you can break this up into you got one person do this and one person do that. One person say this and one person say that. You could do that, or you could just literally pick different. Go up here and do, instead of 20, do 28. There you go. Now you've got a different thing to say. The average.
Just break it apart.
Just break it
So one
apart.
person says, oh,
Let me get through here, sorry.
Just like,
Okay, so we're just doing our group work here.
yeah.
please.
Maybe. Problem is that what are you saying? So talk to me about chicken nuggets. I know I'm vegan, but what? Talk to me about chicken nuggets.
So you can get $1 10 McNuggets at McDonald's. They're not really coffee nuggets, but.
Chicken nuggets.
They're like nicely not that much. But he wants to be
Yeah, so
per member, so let's say you sign in with a different email on McDonald's app, you can get another $10 nuggets. $1.
Okay,
$1 is $1. That's right.
That's tomorrow.
And the $5 meal, that's when you're trying to go, like, yeah, just one, no, like, this is a steal for $6.
Burger King got full on.
Oh, Burger King can just like die.
Yeah.
okay. How's the other group doing? Poor guys. I don't know what the thing does when I leave, but I know it stops sharing. I'm still recording, yes. All right.
Yeah.
So I got some interesting feedback from you guys from my talk.
Awesome.
Nina gave me that was fun sort of feedback, and you gave me I want to do problems sort of feedback. Sarah, what's your feedback about this class?
Like in general,
Yeah, that I can use for my talk next week.
it's unlike.
There you go. Do you like it or hate it?
Math class of the future.
I would have thought you would have liked the Desmos because you got to take the PSATs with the Desmos. That's up. And in paper.
I'm not gonna like any paper, sometimes we come in glitch. That's
Yeah,
why it's good to like double check for sure.
it is, but you know what? You are still gonna find less and less pen and paper in your world.
Don't say that, the truth's been my
That you still take over the world. All right, take care, guys. All right, it's 5:30, so I have to end it all. Take care, bye-bye. I'm ending it all. Uh-oh, I'm not ending the meeting for all. I got into breakout rooms.